Okay, good morning. Welcome to
FamilyMath number 100.
100. I said good morning. I didn't mean good morning. I mean good evening, right?
Yeah.
Okay, so we saw a really cool video a couple weeks ago. In fact, you know what? I don't even remember where we saw it. I think I must have seen it on Twitter or something. And it was a video about cryptography and explained one way that you could send a message to someone, and even if it got intercepted, the interceptor wouldn't know. So I'm going to be the bad guy, okay?
Yeah, okay.
So you're going to try to send this box to your brother, and I'm going to try to intercept it every time.
Okay.
So the first thing you do is what?
I put a lock on it.
You put a lock on it, and then I intercept it, and I'm like, oh darn it, it's got a lock on it. So I say, well, okay, never mind, it's got a lock, and you've got the only key.
Yeah.
And now it gets to your brother, who doesn't have the key, so he can't open it either. So he puts a lock on it and sends it back to you, and I intercept it. Ha ha!
But now there's two locks on it.
Oh shoot! Now there's two locks, so I can't intercept. I don't know what to do. Okay, so now I give it back to you and say, okay, well, good luck. There's two locks on it.
Now I take my lock off.
And you send it back to your brother, and I intercept it again, and I say, oh shoot, there's still a lock on it, so no one's going to be able to do anything. Your brother gets it, and he takes his lock off, and now he can open the box and get whatever special thing was in that box. Which, who knows what that was. Okay, but when we communicate, like on the internet, for example, on our computers, they don't send boxes back and forth to each other, right?
No.
They'll do some boxes of like electronic boxes.
Yeah, exactly right. They send a little electronic boxes. So I'm going to show you one clever mathematical way we can do this where we don't have a physical box, but where we use some codes. But before that, I need to show you one real quick and cool thing about prime numbers. Now, do you know what prime numbers are?
Well, they're numbers that are they're only a multiple of their self and one.
That's right. They don't have any of the divisors other than themselves and one. And then we also have to talk about remainders. And what are remainders? You know.
There's something left over from a division if you don't want to use fractions.
Okay, and so primes have a neat property. So I'm gonna use 5 as the example, but in real encryption they use much larger primes. Okay, so primes are 5, and 5 has a neat property. I'm gonna make a times table here of all the numbers up to 5. 2, 3, 4. So 0, 1, 2, 3, 4. And let's start by multiplying 2. 2 times 0 is
0.
0. And what's the remainder when I divide 0 by 5?
It's just 0.
0, right. Okay, 2 times 1 is?
It is just 2.
What's the remainder when I divide 2 by 5?
It's 2.
2, okay. 2 times 2 is 4. What's the remainder when I divide 4 by 5? You know?
Well, 4 divided by 5, it's, well, 1?
No, 5, there's no 5s. It's 0 times 5 plus 4. Right?
So
The remainder is?
it's 4.
4, very good. Now 2 times 3 is 6. What's the remainder when I divide
1.
6 by 5? 1. And 2 times 4 is 8. What's the remainder when I divide 8 by 5? Right?
3.
3. Now one cool thing is here, you saw all the numbers. 0, 2, 4, 1, 3. That's all the numbers. 0, 1, 2, 3, 4. They just got shuffled. Okay? Now what about 3? 3 times 0 is 0. So the remainder when I divide 0 by 5 is?
0.
3 times 1 is 3. What's the remainder when I divide 3 by 5?
It's 3.
3, very good. 3 times 2 is 6. What's the remainder when I divide 6 by
1.
5? 1. 3 times 3 is 9. What's the remainder when I divide 9 by 5?
4.
4. 3 times 4 is 12. What's the remainder when I divide 12 by 5?
Well, 12 is 10 plus 2.
Yeah.
And 10 is 5 times 2, so the remainder is 2.
Very good. Good job. That's a great way of thinking about it. Notice I got all the numbers scrambled up again. Okay. So looking at remainders when you do multiplication is a really cool way to scramble up numbers. And you can also unscramble them too. So notice if I take, well, I don't want to go into that. There's a way to scramble them up, and would you just believe me that there's a way to unscramble them?
Yeah.
Okay. So that's really neat. So what we're going to do is we're going to send a message scrambling up numbers by multiplying them. Uh-oh, where's my other lock? Oh, here it is. So this is our lock from our movie when we discovered the combination of this lock. And you remember it was 21,
39, 21.
39, 21. And we're going to do this, we're going to look at the remainders using the prime number 101. So you're going to send this lock to your brother, and I'm going to try to intercept it. But so if I figure out it's 21, 39, 21, then I'm going to know.
Yeah.
Haha. But what you're going to do is you're going to multiply the numbers initially by 10,
Yep.
42, and 19. And then you're going to take the remainder when you divide by 101. So you're probably going to need a calculator, right?
Yeah.
It turns out those numbers are 8, 22, and 96. So I get this lock and I see these three numbers, 8, 22, 96.
Yeah.
And
You
it doesn't work. And so I said, okay, that doesn't work. So I give it to your brother. Now your brother's going to multiply by 12, 13, and 15 is what the numbers he chose. Then he's going to take the remainder. So he's going to scramble them again. And that's going to give 96, 84, and 26. Again, 8 times 12 is 96, so you can see that.
yeah.
22 times 13 is whatever, but when I divide by 101, I get a remainder of 84. So he sends it back. Okay.
And the cap.
And the pen cap. And I get 96, 84, 26, and that's not the combination either. So I give it back to you. Oh, I don't know what this is. Now you undo your multiplication. Remember I said there's a way to undo the multiplication? Okay. You now multiply by 91, 89, and 16. Now this is the tricky part. Multiplying by 91 undoes multiplying by 10.
Ooh.
That's cool. Multiplying by 89 undoes multiplying by 42, and that's the cool mathematical theory. And that's something that's very difficult to figure out, for me to figure out what's going on. But you do that multiplication, and now you get 50, 2, I think, yeah, 2, and 12. And you send it back to your brother. And I intercept it one more time. So that combination doesn't work either. So I give it to your brother, who now undoes his multiplication by multiplying by 59. Multiplying by 59 undoes multiplying by 12 for this prime. Multiplying by 70 undoes 22 for this prime. And multiplying by 27 undoes, 12, 13, I meant. Multiplying by 70 undoes multiplying by 13. And multiplying by 27 undoes multiplying by 15. And when he does this, he gets the numbers 21, 39, 21. And notice I intercepted it every time, and I had no idea. I couldn't figure it out. Couldn't figure out the combination. So there you go. So these multiplication.
Bà má con mà có chuyện nữa rồi. Chào cô chú, lâu quá không giờ gặp. Đã là trai Hàn Quốc trưởng thành, hiểu chuyện và thương mẹ, nên con sẽ sang lại cái kênh này cho tiệm mì Bam Bam, bù lại ba lốc sữa. Vốn dĩ con là đứa mê sữa mà, nên bà làm gì kệ bà đi, con có sữa uống là được rồi. Cái kênh của quán con á tự nhiên bị chú TikTok cấm vĩnh viễn luôn. Thôi không sao, để con ra tay bảo vệ mẹ. Tạm thời cô chú coi đỡ kênh này nha, chừng nào hết sữa con đòi lại sau. Lễ lộc thì ngày nào nhà con cũng mở cửa. Má con nói cũng chỉ vì chén cơm manh sữa của con thôi, mà người ta cho mượn kênh rồi thì làm sao cho coi được á. Lạng quạng nước do gạo 11 còn không có, nói chi là Ensu ha bà Mia. Trời Sài Gòn dạo này nóng quá, qua mai chắc con cũng làm lại tô mì lạnh. Mẹ con rủ bữa giờ rồi mà tại con bận đi học. Cô chú thèm thì